as I said, this is Hamid Jafar, Technical Sales Director. You can contact me through LinkedIn, email, and the phone number, WhatsApp. So if you have any question, if you need my advice or my team's advice, then just keep in touch. Hey, SQL Server overview. So in this session, we are going to talk about SQL Server and the product overview and the components. I believe most of you that joined this event already heard about the SQL Server, or your company or yourself is using the SQL Server. SQL Server evolved since 1985, a lot and a lot. I can say that evolved few hundred folds. Um, First, it was known as a database engine, and everyone knows here, oh, SQL Server, oh, it's a database engine that we can keep our database and the tables and the schemas and the querying the data and retrieving data. But a lot of things added. In 1985, SQL Server belongs to Sybase. And later on, Microsoft joined with Sybase and developed the SQL Server 6.5. Then after that, Microsoft decided to purchase the SQL Server product from Sybase. Then they released SQL Server, or I can say Microsoft SQL Server 7. Then in year 2000, they released SQL Server 2000. But in this year 2000, SQL Server was only having a database engine and a kind of integration services. But that time they call it DTS packaging, data transformation service. It was very basic tool for ETL processes. Then what happened? In the year 2005, Microsoft introduced analysis services, introduced reporting services. Um, then it expanded the ecosystem. In year 2008, Microsoft introduced Polybase, but Polybase was not in Enterprise Edition or the Standard Edition. It was actually in the Parallel Data Warehouse Edition of the SQL Server. That Parallel Data Warehouse SQL Server came with hardware. And in Malaysia, only two companies they are having this, or they had it. Maybe right now they already um, out of support, so they don't use it anymore. One bank and one insurance company. It's a huge hardware, comes with multi-level of servers. The language, also the coding, it has few other options like heap clustering, master node, slave node, and so on. It's something similar to Azure SQL DW that time. So the Polybase introduced in year 2008. Then another feature introduced in year 2008 R2, 2010 with the 2008 R2 was master data services, but it didn't comes together with SQL. You should go to the installation image, then you search for master data services, then you install it separately. In 2012, they introduced it and you could install it at the same time. In 2014, they introduced data quality services, Stream Insight. In 2016, they introduced intelligent over any data, which means that machine learning. In 2016, you could run R language over your database and the data. Then they separate it and they make it as a Microsoft R server, but again, we still have R language and SQL Server. In 2017, they introduced SQL Server as a kind of cross-platform solution, which means that you can install on Windows, you can install on Linux, you can install it on Kubernetes, you can install it on Docker, and also it supports more languages and it supports more driver for Ruby, Python, Node.js, and so on. In 2019, you were able to install and run Java codes as well in SQL Server. So we had Java, R, Python, and .NET Framework. And in 2022, they have the Azure, the the pure view, and the SQL Server ledger services. So you are able to audit and do the ledgering on your data. A lot of other features and components added. In SQL Server 2017, Microsoft also introduced another service called SQL Server Reporting Services with Power BI, which they call it later on Power BI Report Server. So these are the history of the SQL Server and the evolution of the ecosystem. But let's go through one by one of those features. What database engine does, it keeps, stores, sort, and filter the data that we want to store or we want to retrieve. Analysis services is a service that it ensures and it come out with the cubes. Analytic services is like um, we can analyze, dice, slice our data, slice and dice they call it, and come out with the result. We are able to do data mining as well in analysis services. We can do decision making algorithms. We can do a lot of things in analysis services and data mining services. Then reporting services is for generating report. 10 reports usually. Let me check it out. Okay, then we had integration services, which we have is for ETL process. Polybase is to get data from unstructured data sources, or is able to connect to Hadoop and retrieve the data. Stream Insight is for hub and event processing. Let's say you have IoT devices, then you are able to use Stream Insight to capture the data and process the data. Master data services is for keeping the master data, sharing the data between the servers, and also between the systems, and versioning the data as well. Data quality services, you are able to cleanse and clear the data. And if there's any dirty data in your database and the tables, then the data steward is able to clean it as well. So these are the overview and the component of SQL Server. The next that you need to always consider when it comes to purchasing the SQL Server and getting advice, some of my clients they ask, oh, can you advise us which edition we should buy, enterprise or standard? Then I explain to them what's the difference between standard and the enterprise, but not the way that Microsoft explained, the way that it suits them. So usually Microsoft explain and compare enterprise and the standard edition by the features. But I don't really go on that. I go beyond that. What we do, I explain as what feature enterprise edition has, as I call it hidden gems, which Microsoft never reveal it. Enterprise edition has many features, and top four I can say here is the advanced scan, hash match role reversal, data page prefetching, and single scatter scan. So when it comes to advanced scan, when we have few users and a single type of query, like just imagine for reporting purpose. If we have user A run query A and user B run query A, same query, same parameters. If user A run it earlier and fetching certain amount of data and user B run after user A, it's actually going to merge both the results and combine together and share between two of them. It runs faster and the algorithm is merry-go-round algorithm. Another feature that is only an enterprise edition is the hash match role reversal. In the query tuning, hash match joins, which it can be hash match inner join, outer join, right join, left join, and so on. The hash match itself is quite expensive. Um, and it only happens for the tables that are huge. I mean, the first table or the left table is huge and the right table is small and both are unsorted. What happens? SQL Server will try to hash, then try to join and see which record is similar. So if let's say the inner table is big and the outer table is small, the performance is good. But if let's say the outer table is big and the inner table is small, the performance drops significantly. SQL Server Enterprise Edition, it will exchange the roles, which means that the inner table become outer table and the outer table become inner table, and evaluates whether this new way of role reversal, it will improve the performance or not. If it does, then it will keep running it as it is. Another feature here is the data page prefetching. It's like caching. We always know that SQL Server copy the data from the disk to memory and try to retrieve the data or modify the data through the memory. But one thing we don't know is that if let's say we run a query and our query is accessing two tables, sales header and sales detail, then SQL in the Enterprise Edition, it will fetch both tables at the same time from the disk if it's required. But in the Standard Edition or other editions, it actually does one by one. It will fetch the first table, I can say the sales header. Once it fetched from the disk, completed, then it goes and fetch the second table, which is sales detail. It takes a lot of time and a lot of I/O. And another feature that improves the performance is the single scatter scan. If the data is, that our database, even though it's single file or multiple files, the data pages inside the disk is already scattered. They are not at the same place. They are not next to each other. So what happened when it comes to the searching and the SQL Server try to read the data from the disk? It can be SSD, it can be the spindle disk, doesn't matter. So when it comes to that, it will check the logical and the physical location, and it tries to read and gather the data that they are all together physically, then it will read it at the same time. It will save a lot of IOPS. So if let's say you run a query in Standard Edition, it takes 10 seconds with 1000 IOPS. In Enterprise Edition, it will take maybe 1 second with 100 IOPS. Is less. Same query. You just run it in different edition, you will see the performance improvement. That's the hidden gems. It has other features which after the event, I'm gonna share with you the documents, the material. You are able to read and review it and even practice. So any questions so far? If you have question, you may unmute yourself and ask your question.
Mr. Hamid. Hello,
Yep.
Mr. Hamid. I'm Azhar from MSC.
Hi,
Okay.
Ashar. Yes.
Nice to see you. Okay. Actually, I want to know that regarding the enterprise and standard edition.
Hmm.
So, let's say lah, for the enterprise, it based on huge transition or based on what you mentioned previously, that one.
Yep. You mean this one?
Yeah, this one. Okay.
Hmm.
So actually, another function for the enterprise is the fast recovery. Okay.
Yep.
So let's say lah, let's say is that we can use that for let's say we have data more than 4 terabyte. We can
Hmm.
should be select standard or enterprise edition.
It's better to be Enterprise Edition.
Uh-huh. Okay.
Okay, the reason is, as you say, the recovery.
Mhm.
So in the Standard Edition, if you restart the server with 4 terabyte of database size and the
Okay.
log file maybe half TB, for
Yeah, yeah.
example, or
Okay.
200 GB, you will
Mm-hmm.
see the database is in recovery mode.
Mm-hmm.
It will
Okay. Okay.
take some time, maybe half an hour or even 1 hour to come up and become online. But in Enterprise Edition is the instant online. The reason is in the enterprise edition, every transaction and the locking, it has the lock information inside the transaction file. But in the standard edition, we don't have. So
Mhm.
when you restart the standard edition of SQL Server, the SQL requires to scan and read the entire transaction log file and check any transaction been rolled back or not committed, or is the, during the restart there was open transaction, so it needs to roll back all the transaction. That's why it takes a lot of time. But
Mhm.
enterprise edition doesn't do that. It will do it in the background. So it will
Okay.
let the database to be online and do it in the background.
This what you call fast recovery lah for the
Yep,
enterprise. Okay,
correct.
actually for the normal database like the standard edition should be used for that development and maybe the for the small data lah for that business.
Yep. For the
Yeah.
development, I suggest that you get
Mhm.
developer edition.
Mhm.
So it's similar to Enterprise Edition. So you are able to test all the features like encryption, like compressions, and so on.
Mhm.
But for the small scale databases, like maybe 100 GB of database or 60, 70 GB of database,
Mhm.
Standard Edition is sufficient.
Okay. If data is more than 3 to 4 tera should be run in using that
Definitely, yep. Needs
enterprise,
to
eh?
be Enterprise Edition. Yep.
Also that we can proceed with the high transaction lah. Especially.
Exactly.
Okay, thank you very much, Mr. Hamid.
You're welcome.
Okay. Okay.
Most welcome.
Okay.
Any questions?
Uh,
Yep.
Encik Hamid,
Yeah.
I'm Chong Lee.
Hi, John.
Comparing the standard and enterprise edition, I would like to know when we're doing the backup of the database,
Mm-hmm.
we can choose to compress the backup set. So
Correct.
enterprise edition actually can compress more compared to standard edition.
Correct.
Do you know what is the compress ratio for standard comparing to enterprise?
Standard back in 2017, the compression was like uh about 30 to 40%. But same database, when it comes to Enterprise Edition, it can go up to 70, 80%. But again, in both scenarios, all depends on what data type you choose. If let's say you choose a data type for var binary in your tables, it's not able to be compressed. But if you are choosing integer, you are choosing nvarchar or varchar, then it's able to compress a lot.
Mm, understand.
Yeah,
Yeah, because one of the reason we choose the enterprise also because of the
compression,
backup can compress a lot and then we can save a lot of space to store the backup set.
correct. That's true.
Mm, okay, thank you.
You're most welcome. If no further question, then we can proceed in the next slide. So now we know what's the difference between enterprise and the standard. And some of the participants, they shared their experience. And also we know that the history of SQL Server and the components of the SQL Server. So now it's time for hardware resource planning, which I believe if you guys are in the IT and IT department, I'm sure you have been, cross this thing that, hey, we want to purchase the new hardware, new SQL, and it comes to the meeting. What is the spec? What we need and how much we need? How many cores? How much of the storage? How fast is the CPU core? How fast is the disk? How much memory is needed? How many network adapters are needed? Then these questions need to be answered. Definitely, we cannot find the exact hardware resource spec for our environment, but if we can reach 90 or 85% close to what we need is the best. So we don't go underestimate, we don't go overestimate. I have seen some companies that they go for overestimate. Let's say they need 10 cores, but they go for 16 cores. By number, it's only 6 different, but when it comes to license cost, it's a lot. when it comes to the hardware cost is a lot. So we want to make it as close as possible. If it requires 10 at the moment, maybe we just purchase 12 or 14 cores and we cater for the next 5 years growth. So these kind of things we need to plan. And how to plan it? Maximum consumption rate. This is something that we need to do it during the UAT environment. Let's say you are going to purchase the new application and your application vendor says that, oh, I need SQL Server to host my SQL database and I need 20 cores and 256 GB of memory. Then you will say that, okay, this is for 5 years. Then they will say, yes, this is definitely for 5 years. But how are you sure that this is sufficient for my environment? It can be sufficient for different companies or different customers' environment. But how are you sure it's sufficient for my environment? Or are you sure it's not overestimated? Maybe I just need 128 GB of memory and 10 cores of CPU. Why do I need to purchase 20 cores of CPU and I need to purchase the license and so on? If they cannot answer you, there's a way to do it, which means we need to have a base environment. Like for example, we go for UAT environment during your testing POC. Then we collect the data from the database. And once we collect it, we come up with this calculation, which means average logical reads divide by average CPU time per query. So if let's say you run the application for a day, you need to capture all the average logical reads for all the sessions and the average CPU time in second for all the sessions, then times it by 8 divided by 1024. That will be your maximum consumption rate, the MCR value. So now it comes to the number of cores. Number of cores matters here because when the licensing is bound with the cores, and that's the extra cost. If let's say the memory amount is still remain 256 GB, it's not that expensive compared to license. License is killing. So to get the required cores and the licensing, we get the average query result size. Query result size means the result set that you run a query and it returns the data and the result set. How big is that result set? By MB, then divided by the value that it's already calculated, the MCR, times by concurrent users, divide by target time. What is target time? Is your business tolerant time, which means if you are going to generate a report, then the business says that I only can wait for 10 seconds to generate the report. Then you need to divide it by 10. If business says that my tolerance is 5 minutes, then you divide it by 300 seconds. In that case, you are able to find out required number of processor cores. Got it? So what happened? You already have the server, but after 5 years, you want to renew it. You want to do the touch update. You need to purchase the new hardware and you need to install the new OS, new SQL, do the upgrade and the migration. You need to do the same thing in your existing environment. Then you find out how much core is needed. Sometimes your current environment is underestimate, which means it requires 20 cores or 30 cores or more or less. But what you have right now is less than what you need. Then you need to increase it. Or what you have right now is even more than what you need. Then you need to reduce it. This is something that it will help you to budget your projects, your upgrade project, touch update projects, and also is something that you have something like solid um, result. You will know that what and how much cores is being used by this app and this database server. The next one is you need to do the network performance test. This network performance test is very simple. From your application server to the database server, or from your client side, which is like, for example, your laptop or your PC or workstation, to the SQL server, you just need to do the ping. You ping the server with the buffer size of 4 KB, is a -L 4096 is the buffer size. Then you need to look at the time. See here, the time. It needs to be less than 10 milliseconds. And the average also less than 10 milliseconds. We should not have any loss packet, and it needs to be consistently less than 10 milliseconds. This is the network performance test. Some people, they think that, oh, the network throughput is high, but actually SQL doesn't look at the throughput. SQL doesn't use the SMB protocol. SQL uses the packet sending in 8 KB or 4 KB packet size. So we need to ensure that the latency is low. Otherwise, you will see a lot of queries waiting for network resources, and it causes the performance issue. This is something that we need to tackle it. If, let's say, your network adapter is, is the bottleneck, then you need to add on another network adapter. Then you do the network teaming in the Windows Server. So once you do the network teaming, then you will reduce actually the latency, the time. And the next is the storage performance test. The storage needs to be fast enough. The ideal for SQL Server environment is less than 10 milliseconds. Read and write, random and sequential. If it's between 11 to 20 milliseconds, the SQL Server performance will be impacted. And if it's more than 20 milliseconds, definitely the performance is impacted. And if you can solve the disk performance issue, then you will see a lot of improvement in the performance of your database server and the queries. So when should you do all of this? Actually, before you install the SQL Server. So what I'm going to teach you here is more on preparing the new environment. You should not do all these tests in your existing environment because it will impact the current environment's performance, and it might cause, the business transaction issues. It might cause a lot of slowness in the application. Let me show you how to do the disk storage test. I have prepared an environment in Azure. I created the disk, but we are going to test even the Azure disk, whether it suits the SQL Server environment. Anyway, I choose the medium range of VM. I just want to check with you. Do you feel lagging or my voice is breaking?
No, you're loud and clear.
Okay, that's great.
All good, all good.
Perfect. So here what we have is an Azure VM. We have C drive, D drive, and I added 2 more disks, 1 TB each, but we haven't provisioned. So let us provision the disk first. I'm going to provision 2 volumes, each disk 1 volume, 1 for data file, 1 for log file. I have these 2, these 3. They are online. I'm going to make a new simple volume. The D drive will be for disk. Sorry, the E drive will be for data file. So this one, data files. For the data files, the allocation unit, we usually go for 64 KB. What's the reason behind this configuration? For the data file, SQL Server reads 8 data pages at the same time, which means 64 KB at the same time. And each extent is 8 data pages, again 64 KB. So when we allocate when we set the allocation unit size 64 KB, it's easier for SQL and the OS to extend the database file, read and write as well. It's easier. And for the log file, we go for 4 KB. The reason behind is because SQL Server, when the log buffer reach 4 KB, it actually flush the log file and it writes it into the disk. Perfect. So um, for the disk test, we have one application which again is developed by Microsoft called Disk SPD. Disk SPD is the general app for testing the disk, but it has kind of parameters which we can use and simulate the SQL Server environment. Let me show you the batch file. So here what we have is the parameters. It says the capacity. I just put it 20 GB. The buffer size, the block size, sorry, 64 KB and 4 KB. It's random. The threads is 16 threads, one outstanding thread. Dash H and dash L is for skipping the hardware caching. So we want to try and test the disk itself. We don't want to go through the caching process, because what happened in the new generation of disk, we have a cache, and from the cache it writes it into the disk. So if let's say OS send the IO request to the disk will cache it, then send the acknowledgement to the OS and say, okay, I already written, but actually it's not written into the disk, it's just cache it. Then it will asynchronously go and write it into the disk. We don't want that caching process. We want to make sure if let's say we bypass the caching, how fast it can go. This is 40% write, 60% read. So this parameter -w is for write. Whatever value you set here, the balance is for read. And the duration is the 60 seconds. This is the path for data log file, data log file, data log file. The reason is we want to make sure which drive and which disk is suitable for data and the log, or data and or log. So we can either keep data and the log together or we separate them. And you can see here that for the log file is almost the same, except the thread is 2 because in SQL Server, per NOMA node is 1. So this server is having 2 NOMA nodes. The soft NOMA node, we create 2. We bypass again the cache and we make sure that 100% writing in this sequential mode. If we don't put R is actually the sequential mode. We close it. I want to run it in CMD and also would like to keep the result. Test. Disk IO test. Test result.txt. So the D drive, the test data has been generated. It's trying to do the read and write. Let us check the resource monitor. Okay, is reading and writing. The response time is quite high, is 57 millisecond and 2. Now it moved to the log file. Meanwhile, let's review the result. One of it here. The first one is 20 GB, 64K block size, 16 threads, random, read and write. So when we look at this one, we have here is the CPU threads that's been created, the usage, users, kernels, and so on. And here we have the total IO per threads that we have, 16 threads. The number of IOPS that is been handled by each thread, and the megabyte that handled by each thread per second, and the IO per second, and the average latency. So overall average latency is 2.6. Here for the read we have 2.6, 2.5. For the write we have 2.6. Overall, this D drive is good for read and write random, but we need to see whether for the sequential it's okay or not. And this is the histogram. When it comes to read, write, and the total time, and this is by the percentage, it's like 99%, it took about 45 milliseconds to read and 46 milliseconds to write for 99% of the percentile, actually is the 99th percentile of the operation, and the minimum and the maximum, the 25th, 50, 75, 19, and so on. And let us check for the log file as well. This was for the data. Now, this is for the log file. LDF is the sequential IO. And we can see is the 2 threads, so it can transfer 59 MB per second. Write doesn't have, and average latency is less than 1 millisecond, which is perfect. But the throughput, because of its 2 threads, is not much. So we can even keep the log file here in this drive. And we test all the drives, same thing. Then we read the result. If you see any average latency more than 10 milliseconds, then you need to, I don't know, raise a ticket to your hardware vendor, or you mention in your meeting that, hey, we test this server, you know, it can cause a lot of performance issues in future. And you know that we are testing before installing SQL and before using the disk, because when the disk is fresh, it's usually faster. And once we have a lot of data inside the disk, it's getting slower. Same thing happened to the SSD. The SSD rule is you need to only fulfill 70% of the SSD capacity. If it goes more than 70%, you will realize the SSD drive throughput is dropping. The latency is increasing. And after a few years, you might realize that, oh, the SSD is dead. It doesn't work as before. In that case, they call it zombie SSD. Zombie SSD is the time that you need to remove the disk, you need to reformat it, and put back inside your storage server or the storage system. Then it will try to recover it. That's the SSD behavior. It's same thing goes to even your laptop. First time you install the SSD, it runs so fast, copy, cut, moving the files is very fast. But after a few years or after the time that the drive is or the disk is quite full, then you will realize that the performance drop and it's getting slower. This is something that we need to take care, especially for the on-prem servers. So any questions so far? Yep.
One question about the network performance test just now. Did it apply to the
Yep.
Azure database that sit in the cloud as well, or is it on the prem only for the on-prem DB?
Is actually between the app and the DB server. So if let's say your DB is on Azure and your app server is on-prem, then you need to do the testing as well. But if let's say both are on the cloud, you don't need to do testing because definitely that is below 1 millisecond. So any other questions?
The question about the MCR just now.
Hello, Hami.
Mm-hmm.
Yeah, I posed a
Yeah.
question on the chat box.
Okay, let me check. Um, yeah, Hafimas, sorry, you were asking about the MCR. Yep.
About the concurrent user, can you explain about the
Concurrent users, when we look at the SQL, like we have the concurrent executions. So we can have concurrent user, like people say we have 100 or 300 or 400 users, but actually not all of them running a query at the same time. So we look at concurrent user as the users that they are running a query at the same time. So maybe 20, 30 out of 300 or 400.
The concurrent user is the apps user or user that connect to the
Is a session, I can say. Is a session. Yeah. Okay, let me check for Go. For the target time calculation, one report tolerance level is 5 seconds, and another report tolerance level is which target time should I take? You need to take the 5 seconds, because if you take the 30 minutes, then the number of cores will reduce. Then it cannot meet that 5 seconds. So you need to take the lowest all the time.
Taking the lowest means 5 seconds.
5 seconds, yep.
Okay.
Any other questions? Nope. Okay. Once you measure the hardware and I mean the resources that needed, you set up the Windows, you do the network test, disk testing, and everything pass. It's time to set up and configure the SQL. And at the same time, configure the OS as well. When it comes to the OS installation and the configuration, I recommend Windows Core. But Windows Core doesn't have GUI. It's only command prompt and the PowerShell. I believe that it might be troublesome for a lot of um, IT people, because with the codes, it takes a lot of time to type it, to find out, and so on. GUI is easier. But the other side, the GUI is having a lot of patches. So when we do a lot of patching in the Windows, is we are actually patching the GUI features, not the core features. So if you install the Windows Server Core, you will reduce the patching time as well and the patches as well. Like for example, right now you are patching almost every quarter. Then in that case, you are going to patch only twice a year or once a year. And after we install the the Windows Server, we need to configure the file system and the group policy as well, which I'm gonna show you how to configure it. That configuration is I can say is the main and the best practice configuration you need to apply to all your SQL Server environment. Once the Windows is set up and configured, then it's time for SQL Server installation and configuration. The best practice for SQL is to install only the feature and the component that is needed. If you don't need reporting services or analysis services, do not install it. If you install it, it's fine, but ensure that the service is stopped and disabled. Otherwise, every time that it run or restart the server, then the service will automatically start and run and consume a lot of resources. We don't want that extra resource consumption. And once it comes to the installation, you need to separate the data and the log files in different disks. Once you separate it, you are good to go. Installation is done. You need to configure the SQL, the port, the security features, and also the service account. We should not use the default service account. We should not use the default port as well. The ports must be changed. The reason is attackers and the cyber attackers, they always attack the default port, 1433 TCP. And do you need to close or block any other port? Yes. You need to block port 52, 53, port 1433, port 1434 TCP and UDP. The reason is some hackers, they use the port query application and they are able to connect to 1434 TCP, and that is the browser service. They will query for your SQL Server instances, and that service will return all the information to the hacker. So we need to disable the browser service, at the same time change the port and block the unnecessary and unneeded ports as well. Let me show you the file system configuration, service account, GP edit, and also the installation and configuration of SQL Server. Okay, these testings are done. Let us remove the files. Before installation, we need to do some file system configuration. We open the CMD, run as admin. We go for fsutil. This fsutil is for the file system. You need to be very careful. Don't do any changes after installing the SQL unless it's needed. If you do any mistake here, the file system might not be readable. You might lose any data and so on. But don't worry. Whatever config that I show you here, you just do it in your environment. It doesn't harm. It has benefit as well. One thing we need to um, set is the behavior of the file system. We don't look at other things. The second one is the behavior. So fsutil behavior. So in the behavior, we have two things, either query or set. So we are going to query. So we have all these features that we can set it. One thing we need to set is the disable, delete, notify. Okay. And we need to disable last access. We need to set memory usage. We need to set MFT zone. And we are done. So let me explain to you what is it. Disable, delete, notify, which means that after every file delete, it doesn't need to notify the operating system. It just delete it. So the notification will be silent. Disable last access, which is very important. Any file that has been accessed by either user or the application or the service, it doesn't need to update the last access. So what is last access? Is actually is a metadata of a file that when you right click on any file and you click on properties, you have this one accessed. So this is the last access. And every time it get updated, every time I open, then do some changes, save it, then it will be updated. We don't need that. The reason is SQL Server is keep on reading, updating, storing files and the data. And it will take a lot of time for the file system to respond to the operating system and then respond to the SQL. It will reduce the performance. What we do, we just here we set, disable, delete, notify, and TFS. Okay. It says that the boot is needed. Disable, delete, notify, TFS. Okay. So disable, delete, notify for NTFS is enabled, which means that it doesn't notify anymore. Then the next one is disable last access. One enable. And the next one is memory usage. Memory usage I set 2. What is memory usage? When actually the operating system, the Windows Server, when you access a file or a data frequently, then it will try to cache it inside the memory. So it doesn't always go and read from the disk. By this one, we are going to expand the memory capacity for caching into double. And that's the maximum. So we have 1 or 2. So we set it 2. It actually double it and it requires reboot. Then the next one is MFT zone. So MFT zone is zone. is for the file system repository. Every file, folders, and the path that we can see inside the, for example, inside this Explorer is read from the MFT zone. And if let's say you have a lot of files and the folders inside the drive and the volume, when you try to browse it or it try to load it, it will take longer time because the MFT zone is limited by default is 1 means 200 MB. And if you have a lot of folders and the path there, that 200 MB is not sufficient, then what Windows Server will do, it will try to compress. It will try to, find the similarities and try to compress it. They call it dictionary. They do the dictionary. And once it does the dictionary processing, it becomes slow. We don't want that. Then we make it number 4. We expand it 4 times, means 800 MB. So translate to a zone size of 800 MB. We need to restart, but we don't do that right now because we need to proceed with other things. Once all of these are done, now it's time for us to create what? The SQL account, service account, computer management. If let's say you are not going to have a Windows or SQL clustering or always on availability group, you have 2 options. You can use either Active Directory account to use as service account, or you create a local user and assign the necessary permissions and use it as SQL Server service account. In this case, I need to create a local user because I don't have the AD at the moment. I just put SQL ACC SRV and I set the password, something very complicated. And the complex must not change, cannot change password and never expire. Done. This is the service account. Now, I need to ensure that this service account is able to access D drive, E drive, F drive, and C drive. So I'm gonna assign the permission, security, add SQL ACC SRV, full control because it needs to access a lot of different places. And the D drive, I just set it for temp DB. It doesn't need to access any other folder. I need to set for E drive user data, security. And the F drive. Full access. Perfect. Then I'm going to install the SQL Server. The ISO file is here. Setup. I'm just gonna install the database engine, SQL replication, and full text. Here, this is the instance root directory, which means the installation files, the binary files. Then we click next. This is the instance name. This is the default instance, or we can change the name. It's fine. Now, here, we need to change it to SQL ACC SRV. And we enter the password. And here, SQL ACC SRV. Enter the password. The rest we are not able to change it, is the service itself. Then we grant the perform volume maintenance task, the collation, we set it as is needed. Then we set the mix mode. Let me set the SA password. And we need to add one Windows account. So we set the current account. Now, it's time for data directory. This is the data root. So the system databases goes here, but the user databases, it needs to be here. I'm gonna change it. I'm gonna put for E drive for this data. And for the log, I'm gonna separate it and put log here. The temp DB, I'm gonna change it to the D drive, the location that I created, D drive, temp DB. If you are installing Azure SQL on Azure VM, the temp DB, it can be on the D drive. If you look at it, the D drive, it says is a temporary storage. And if once you restart the VM, everything will lost. So you are able to create it here. It's not an issue because every time SQL restart also, it will recreate the temp DB data files and the log file. For the temp DB initial size and the auto growth, we set something that reasonable. 1024. Sorry, oh, sorry. Number of files 8, correct. And this one 1024. And here is 1024. And initial size as well, this one 1024 and 1024. Then we go for maxed up. It says eight cores means all the cores, but usually in a production we don't do that. Otherwise, one query can utilize all the cores and the rest of the workload they starving from the CPU. I usually go for 30%, means that this one will be about three cores. And the memory utilization, I mean the maximum and the minimum memory, it goes by default or recommended. So when it comes to recommendation here, I have my own calculation, which I need to use the calculator. Use calculator. I mean, what we set here is actually applicable for 2017, 19, and 2022, because the engine still remain the same, not much different. So 8 cores, then I need to allocate 18 plus 5.8. If 16, 24, 24.2. Then 24.2 times 1024, 24,780. And the minimum, usually I set 10% of this maximum. So it will be times 12478. 2478. File stream feature, if it's needed by the application or the developers, then you enable it. This feature is very useful if your app is compatible, which means that if you save a file inside the SQL, then when you try to query and retrieve the file, your app can use the Windows API to go and read the file instead of asking the SQL to read the file, and it runs faster and more efficient. Once it's done, we click next. We review everything here. Looks good. We install. Meanwhile, that is installing, I'm gonna add the service account into the GP edit. Is the group policy gp edit.msc. What should I change here? Here we need to, why is it like this? Okay, we just go to Windows. It's something that is the best practice we need to do, especially when we create the explicit service account. One thing, bypass traverse checking, adjusting the quota. So let us go through one by one. First, we adjust the quota here. SQL ACC SRV. Then later on is the bypass traverse checking. This is for the network performance. Then after that is the create global objects. Then we come down, we say that deny logon through RDP. We don't want any logon through this service account, SQL ACC SRV. Then force shutdown definitely is not needed. Then another one is the increase of process. Yeah. And log pages in memory. This is for performance. Log on as a batch job. Log on as a service. Then perform volume maintenance task. And done. So these are the configs we need to set in the group policy, mostly related to security and the performance. Wait, once it's done. That might take some time. Okay. Okay, meanwhile, We proceed with the slide. So any questions so far?
Mr. Hamid,
Yes.
yeah, during the installation, let's say we use the default memory allocation and we
Mhm.
did not specify the minimum and maximum memory. What is
Yep.
the impact to the performance?
Okay, during the startup, it needs to load slowly. But if you set the minimum, then it will allocate the memory in lump sum once it's, in during the startup. If you don't set the minimum, then it needs to grow slowly up to the maximum. But if you set the minimum, then it will allocate the minimum amount of memory at first, then it will slowly expand and allocate up to the maximum server size. And if you
Okay.
don't set the maximum server memory, which is not recommended, you still need to set. Um, it can cause a lot of memory related performance issues. And also you might realize or you might face memory starving, or I can say that competing between the Windows Server and the SQL. So when the Windows Server requires memory, it will force SQL to deallocate memory. Then when the SQL requires memory, it will force the Windows to deallocate memory. And it will be a kind of very tight competition between these two systems.
Okay. So we can use the tools, the SQL Server Memory Calculator to calculate the.
Yep,
Okay, thank you
correct.
very much.
Most welcome.
Uh,
That's,
Hello,
yep,
Mr. Hamid, Azhar.
yeah.
Okay, can you focus on the regarding network test from to the SQL server lah, actually? Okay, because right now our experience we are from on-prems to the Asia Singapore. So let's say lah, if we ping, how we can this how we need to measure that in order our connection is okay, or if not, if let's say because currently for
Mhm.
example, when we ping, maybe they're taking about, for example, about maybe 25 to 30 millisecond.
Mhm.
So, okay, this should be okay lah, because be from for example, from the on-prem to
Singapore, yep.
uh, from on-prem to the our local land here lah. So
Mhm.
it's okay or not that for the measurement for that what call it, that the package send and receive that one for the
Usually
30.
25 millisecond for the local LAN is
Mm-hmm,
considered high. If
mm-hmm,
you say from on-prem to your
mm-hmm,
Azure in Singapore
mm-hmm.
is reasonable.
Okay,
But
reasonable,
if within your local network, 25 millisecond is very high. And do you see any packet drop?
No.
Okay. If you
Mm-hmm,
don't see the packet drop, then it's good, but we still
mm-hmm,
need to work on the latency.
mm-hmm. So that means we need to do something lah for the tuning for the SQL network apa regarding network parameter lah inside that
Correct.
inside the VM server. Should be we can
Correct.
proceed that one.
Yeah, that one. And
Mhm.
also you might need to add on the new or additional network adapter.
Okay.
Yeah.
So is any impact of that current transition if we, let's say lah, we access from, let's say we have system from the
Mm-hmm.
local LAN.
Yep.
So the communication to the Asia about 20 to 25 millisecond.
Mm-hmm.
So this is any impact or not, that one,
Um,
regarding
it will,
performance? Mm-hmm.
it will, like for example, if let's say
Mm-hmm.
you are trying to retrieve a data from Azure,
Yeah.
it's about it costs about, for example, one megabyte.
Mm.
Let me do some calculation here.
Oh,
If
okay.
let's say 24 KB, then divide
Mm-hmm.
by 4 KB, 256 times the network needs to send the packets. Then we times it by 25 millisecond, then divide it by 1000. It's
Mm-hmm.
already slow by 6.4 seconds.
Okay.
Yep. So the query, it will run, for example, within a second or two. But for transmitting from the SQL from the Azure to the on-prem application, it will take about 6.4 seconds just to transfer the data.
Okay, there's any impact. Let's say we perform that transition to doing that big transition.
Mhm.
Is in fact to locking or not? Maybe sometimes they log and they will suspend that transition.
Mm.
There's an impact or not that one?
Definitely, that is it will impact, but it's the
Mm-hmm.
different. It's not related to network.
Okay, okay.
If you realize that if let's say it's locking, then you will
Mm-hmm.
see a lot of locking, or the session is waiting for another session, or
Mm-hmm.
blocked, or deadlocked. But if you see in the session, it says the network async network IO. If you see that type of wait, means that you have network bottleneck.
Okay,
The
okay, okay.
bottleneck is in the network.
So this mean let's say lah, can we improve inside the SQL server? Let's say lah, if we have 20 to 25 millisecond that transfer packet
Mhm.
from local to the Asia. So
Yep.
this means they have some tuning like inside that SQL server. We need to do it.
Yes, you can do it, but
Mhm.
one more thing, if let's say you want to tune the network, there's one option in the network switch called jumbo packet.
Okay.
Jumbo packet is up to 16 KB. It can allocate the packet size. And in the SQL also, you are able to set the packet size up to 16 KB.
16
Um,
KB. Okay.
yes. Then in that case, every data packet that it's sent is a 16 KB. But if you have a network, let's say printer in the network, and your application try to send a file or something to the printer, maybe the printer is not accessible or working well anymore because of that jumbo packet size. It happened before. So you need to test everything before you change the jumbo packet size.
Okay, okay. Got it.
Yep.
Okay, thank you. Okay.
You're welcome. Any questions? Okay, this is installed. Let's check MTB created. Perfect. Okay. Then let us try to connect and restore a database. Okay, meanwhile, come here. So no further question from participants? Okay, let's proceed. Security hardening. Once you install, configure, now it's time for security hardening. This is very critical. Even though you don't do all those configurations, hardware sizing, and so on, if you haven't done any security hardening in your SQL Server environment, it's good to do it after this event. At least you plan for it. So in the SQL Server, we have all these security things, but some of it is not in the SQL, some of it is in the network, some of it is the physical security like building, authorization, and so on. We have physical to in-depth security. Let's look at the physical security layer. The building, it needs to be secure. So definitely not everyone should access the building. As every office nowadays, they have these access cards, badge cards, and so on. The server's supposed to be in a secure room, which they call it server room. And the server room, it needs to be accessed by authorized personnel. So from here, we have building and the personal authorization. After that is the network layer security, which we need to enable TLS and the SSL. So TLS 1 and TLS 1.1 needs to be disabled. TLS 1.2 and 1.3, which is in preview, needs to be enabled. And the SSL 2 and SSL 3 also needs to be disabled. That's all. Then it needs to go to the firewall. In the firewall, we need to change the default port, and we need to block certain IPs, the range of IPs and range of ports in that firewall. And in the file system, as just now I did it in the file system prior installing the SQL, what I have done, creating the service account and assigning the full access to only certain folders and the drives, nothing else. So you should not allow anyone to access the database files, and also the server, the SQL instance, to access other drives and the other files that is not needed. Why? Because if hacker try to attack the SQL server and get the system administrator privilege from the SQL server, is able to run the CMD commands, and it's able to access all your data files and the databases, and also other data files as well, like text file or images, PDFs. And they are able to retrieve it through the SQL. They are able to read the file through the SQL and extract it and store it. That's how the data it leaks. Then inside the database server, the SQL Server instance, we need to secure the logins, users, databases. We apply the database encryption, column level encryptions, and so on. But when we talk about the column level encryption, then it will involve the application as well. We need to ensure whether the application is compatible or not. But the database encryption is transparent. You can easily encrypt the database backup or database itself, encryption at rest. So this is how it works. Then when it comes to the TLS and the SSL security for the TDS protocol, TDS is the tabular data stream protocol for SQL Server when it transfers the data through the network. So what happened? This TDS here between the server and the client, it gets encrypted. And the encryption is done not by the SQL, with the Windows itself. So you don't need to worry about whether your app is compatible or not, but ensure is sometimes the TLS 1.2 or 1 or so on, the application will try to do it explicitly. Means inside the code, they will put there, I want to use TLS 1 or I want to use TLS 1.1. So if you disable the TLS 1 or 1.1 in the server, then it's not able to communicate. So we need to ensure that they don't specify it explicitly in the application code. Another layer, as I said, the firewall file system configuration, and we disable the user access to database directories, operating system installation directory, and also we disable the browser service, which we are going to do it during demo. So let us show you a demo here. Let me try to connect and restore a database first. Restore the database. Twice. We look at the files, it's already here, restored here, and the options. Okay. Perfect. Now we have it. It's time to change the port. I don't want to use the 1433. I want to configure the SQL and harden it. First, we use the port. We click on the configuration manager. We click here on the network protocols, the TCP IP we enable. Shared memory is enabled, name pipe disabled, it's fine. We click properties, IP addresses. Here we have this TCP. Let's say 9988, for example. Then we click OK. We use for TCP port this one for all IPs. Once you change this, it will apply to all. Then the next one is we disable the browser service. This is stopped, but we want to make sure that it never run. Okay, it's already disabled. That's good. But if you install the named instance, then it will be enabled. So we try to disable this. The agent will start it as well. Then here in this Windows firewall, advanced settings, inbound, we try to allow specific port 9988, all domains SQL Server port allowed. And another rule for port 1433, 1434 for TCP, block the connection, right? SQL Server ports. Then here, okay, sorry, blocked for, this one is TCP. Another one's for UDP. 1434 UDP. Block it. SQL Server block port UDP. Then the outgoing, we set another rule, port 9988 TCP. We allow it. SQL Server allow port. Create another one. Yes. 1433, 1434. TCP blocked all SQL Server blocked port TCP. And another port UDP 1433, 1434. Blocked domain all SQL Server blocked port UDP. Done. So We have all these ports, this one. Now it's time to restart the service. Okay. Now it seems like, okay, this is connected. It's through the shared memory. So it's not an issue. If we want to connect through the port, let us try 1433. This is the true port. It's not going to connect. It's going to throw me an error. It says that it's not able to find the SQL. We just need to wait for about 30 seconds. Okay, it says that couldn't find. Let us try with 9988. Boom, it's able to connect. So the port has been changed. The next thing is we need to change the SA because all these hackers, they use the SA account and they try to do the brutal attack, which means they use SA with different passwords or they use some kind of login names, funny login names with different passwords. What we should do is we rename this SA account as something else. Like for example, how I do, I will try to make it as a SQL event, the machine name, sysadmin. Then I just put some numbers, let's say 2023, the installation date. This is something that hackers, they are not able to try to access through this login. Something random and you know it. If your application requires to have SA account to connect to the database, but it's not going to use the sysadmin privilege, you can create a kind of fake SA account. So when you try to create the fake SA account, you just key in the password, then let's say the enforce policy. And one more thing, every time you create the new login, make sure the default database is either tempdb or the database that is associated to the login. So I usually go for tempdb. Then the server, we just go for db creator and the mapping, for example, AdventureWorks db owner. Done. If by any chance they try to hack through the SA, they only can access that specific DB. They are not able to control your entire SQL instance, and they are not able to control entire SQL environment and the Windows server as well. Because by SA, the default SA, which is the system admin privilege, they are able to run CMD, and through that, they are able to access your file system and retrieve the data. This is very dangerous. You should not let that SA to be around. Another thing that you need to disable here is the exec. We go for configure. I want to show you one thing that hackers also they try to use is the OLE is under advanced options. So we show advanced options, one reconfigure with override. Then let's look at the config. There's one config here is named OLE. Here, the OLE automation procedures, never try to enable it. If your vendor asks you to enable it or there's a software that using this, is actually putting you guys into a risk, because OLE, automation procedures, is even worse than CMD command. They are able to access the windows directly, and they are able to create the objects. They are able to create the commands that through the OLE, and it's very harmful. Don't try to enable it unless it's needed and you have done all those hardenings. One more thing that needs to be enabled is the C2 audit. For the logins, the login auditing not only capture the fair login, but actually capture the both. And if you want to capture the logins in detail, let's say the machine name and the time, very detailed auditing, then you enable these two as well. Common criteria compliance and C2 audit tracing. These two will make sure that everything is audited in detail. Any questions? Nope. Good. So we provide the complimentary service like health check. If you are our customer, you already know that we do it for you. So for those that they are not our customer, we can do a complimentary health check for you guys. You just need to contact me, then we can provide it. I know that it's been 1 hour 40 minutes, so just 5 minutes break, then we come back and we continue. Thanks. Okay. So the next is proactive administration. Once we do the hardware sizing, we install, configure, we do the security hardening. Definitely we restore the databases, configure the ports and so on. Then the next is the administration. So for administration, you can use scripts or the tools, but internally we use this tool for our clients and managing the environment. So this tool called AIDBA, it collects the health check, it performs the analytics, it generates the script, the reports, documents, and is also able to provide like performance tuning, configuration, hardening, and so on. Is more on the recommendation and advisory. And at the same time, it generates the script as well. So you don't need to even write down or type the script. It automatically generated. It come out with a portal and the service. So um, the service basically is a piece of software that we install at the client server, or it can be the third party server. Um, then after that, we run the service. Once the service is run, then we are able to view the data from here, like portal, then test at partnersolutions.com. Free. Then it goes to the portal. From the portal, we are able to see the recommendations, the servers, and so on. So this is our test demo. We are able to see the recommendations, documents, and so on. We are even able to, let's say, do some commands, all servers. Then this is for the test account, that whether it's deleted or not. Then list all databases. No database at the moment in each server. Let's say list all recommendations. So this is a test environment of, I think some of my other colleagues, they already remove a lot of things. So that's why it doesn't have it. But once you install the gateway, then it's able to collect the health check, come out with the recommendations, and so on. Some of our clients are already using this AIDBA. Yeah, so that is for the proactive administration, which means that it will search and find the issues and search for the resolution. Then it come out with the script. So let me move to the continuous performance tuning. So once you do the administration, you need to make the continuous performance tuning. Continuous performance tuning means you should not wait for user to complain. At the same time, we need to monitor and do the tuning. But sometimes it's unavoidable. Users suddenly come and complain and say that, okay, um, this query or this module or this part of my app or report doesn't work well. Even though we monitor and even though we are doing the continuous performance tuning, but sometimes it happens. The factor it can be varies is that it can be from the network, it can be from hardware, it can be from extra workload that has been added to the system at that point of time. But anyhow, to find out which query is the problematic query, we need to do the analysis. So basically, we have two types of workloads. One is online transaction processing workload, which is OLTP. The other one is the online analytics processing, which is OLAP. So OLTP transaction or the workload is very short, but is huge amount of transaction and the workload, which means that in a day it can go up to million transactions or more. But for the OLAP workload, it can go up to maybe 50 or 100 transactions, but a lot of resource consuming or resource intensive workload. So blocking and so on, like blocking deadlocks in OLAP environment, it's always happen because they are accessing huge amount of data concurrently. In the OLTP, it should not happen because they are accessing very small amount of data, and they are, even though they are concurrently accessing the users, but still should not happen. That's why we have these two different workloads. How to find the problematic workloads? By this query, you are able to find the problematic workloads. Once you find it, you click on the execution plan or the query plan column, the XML column, then to view the execution plan. To tune the database workload, you need to always look for these 4 indicators. One is the index scan. It can be clustered index or non-clustered index. It can be table scan. It can be key lookup, and it can be RID lookup. So what each of them does? Index scan, it will scan entire index. So if it's non-clustered index and small in size, it's okay. It can be, it can happen. But if it's clustered index and it's the table, the index is huge in size and is having the index scan, then that is the problem. We need to make sure that it become index sick to tune the indexes and the queries. Another one is the table scan. Then we need to create index. If it's key lookup and RID lookup, we need to ensure the index that been used for the key lookup and the RID lookup, it has sufficient data. Sufficient data means that those columns or those fields that we are projecting, retrieving from the database is already inside the index. If it's not inside the index, it needs to read from the base table, which it calls key lookup and RID lookup. These 4 operators in the query execution, they are the most problematic operators, and they are the most performance killers. We need to avoid this for as much as possible. Let me show you demo here. Use AdventureWorks. And I'm gonna select asterisk from sales dot sales order header H inner join sales dot sales order detail D on D dot sales order ID equal H dot sales order ID. Okay, let's run it. But prior to running, I want to set statistics time and IO on. Okay, so when we set the time IO and XML, it will come out with the query plan, it will come out with the CPU time and the logical IO. You can see that this one is the asterisk. It retrieves all the columns. It reads a lot of data pages and it runs within 4 seconds. Let's look at the query plan. The query plan, it doesn't look nice to me. We have here clustered index scan, clustered index scan. Even though we have the join, it doesn't really do the filtering and it retrieves all the records. If let's say I want to search for specific cells and specific ship date, like for an example here, and due date equal so 53 less than 1 second, and let's look at it. Wow. Now we have here clustered index scan, clustered index seek. That's good. So here we have the scan. You can see the output. Let me show you the properties. We have the output list, all the columns. We have the object, but there's no predicates. The predicates appear here in the filter. You see, it retrieves all the records. It does the compute scalar. Then it performs the filtering here, which the filtering by right, it should be here, not here. So the filtering is predicate due date equal that. Anyhow, we don't need all the columns. Let us do the sales order ID, order date, due date, status, sales order number, for example. Yeah, it's remain the same, filtering and so on. How to tune this? We need to ensure that we have proper indexes for this sales order header, this guy. Sales order header, yep, correct. Because it's scanning all. We just create index, for an example, var ix01 on sales dot sales order header. Then we go by the columns that is needed. First column is the due date. Due date. Second column is sales order ID. Sales order ID. Then we select again and we look at execution plan. Now it changed to non-clustered index seek, but the problem is key lookup. Why the key lookup happens here? Because it's going to retrieve, if you look at the output list, is the order date and the status, but it searches from the index based on the due date and sales order ID. To retrieve the other two columns, it requires to look back into the clustered index. That's why it mentioned key lookup. This one will kill the performance as well. So what should we do? We basically need to add on, which we call it include the columns like order date and status with drop existing on. Done. We look at plan. Now the key lookup is gone. We only have one index scan and the clustered index seek, which is already tuned. If we look at the execution here, you can see that 102 and 134 millisecond. Basically the tuning, once you identify for the tuning, you just need to play with indexes and the query as well. So if you find out any query that using asterisk, then you just need to avoid it. You need to avoid asterisk. You need to avoid select asterisk from table A, B, C, D, and so on. Okay. Any questions? No questions. Okay. So we go for break time. Then we come back. Okay. So the next is the high availability and disaster recovery setup for your environment. Once you do the hardware sizing, setup, configure, hardening, proactive administration, setting up some maybe alerts and the apps or anything that can help you on the administration. Then you run the continuous performance tuning on daily basis or weekly basis. You do the health check. Now it's time for high availability and disaster recovery setup. But all these two, this high availability and disaster recovery, it all depends on the RTO and the RPO defined by the business. So if let's say you are working in the industry that the recovery time objective is 1 hour or 2 hours maximum, like insurance companies, like banks, like factories, and also the RPO is very low. It can be 0 or maybe 15 minutes. RPO is the recovery point objective, means how much data you are able to lose or you are, you know, tolerated to lose, like 15 minutes data, 1 hour data, 2 hours data. That will define whether you need high availability, disaster recovery, and what type of high availability and disaster recovery you need. So if let's say you are having high RTO and the high RPO, maybe 1 hour RTO and 1 hour RPO, then you are able to use the shared volume cluster, which they call it traditional cluster, is the active passive type of cluster. But if let's say you are having almost 0 RPO and the RTO, then you need to use the new type of high availability and disaster recovery, which called always on availability group. We will have both servers active, they are syncing, and the failover is within 10-15 seconds, it fell over. And when it comes to the disaster recovery sites, then you need to define if anything happened to your primary servers, how long do you have to come up and set up the DR site, or you run the business from the DR site. If you are running or working with banks, insurance, factories, the D again goes back to the RTO and the RPO. You need to have hot disaster recovery design, which means the servers, Windows, SQL, databases, and the config and the apps need to be already set up, and it's just ready for failover. That's all. But if you are working in the industry that the disaster recovery, it doesn't have much impact, and the RTO, RPO, it can be high, then you can go for warm DR or cold DR. So what's the difference between cold, warm, and hot? Cold DR, which means that your company purchased the hardware licenses, but they don't assemble the server, they don't install the software, they just keep it in the server room or the data center. Warm DR is the one that your company purchased the hardware and the licenses. They set up the hardware, licenses, they install the Windows and the SQL, but they don't restore the databases. So when it comes to warm DR, the databases will be restored from the last offsite backup. And the hot DR is the one that DR and the production, they are in sync, and they work and synchronize 24/7. Any questions about the DR and the high availability design? And in case if you have any design in your mind, yeah.
With always on, right? The DB. What is the
Mhm.
recommended size to keep high availability?
You mean they're always on recommended size in terms of the DB, you mean?
Yes.
I mean, there's no recommendation as long as the SQL can support, which it can be the 5 petabyte. I have a client that they are running on 2 TB DB on always on.
The
So
replication on 2 TB.
yeah, 2 TB they are running, and some of them they are running for 50 GB of database. It all actually depends how critical is that database and what is your RTO and the RPO.
Let's say we have 10 TB of DB.
Mhm.
So can we sync this one always on and the secondary node we can sync this one? I mean to say.
Yes, you can, but you won't be able to sync like ordinary syncing, like normal syncing. So you need to use a kind of technique to move that 10 TB, then you restore it, then you try to sync it manually first, then after that you flap and, or I can say that turn on the always on for it. Then the always on will continue syncing.
First time you need to say you need to do a manual. You mean to say, right?
Yep,
After that it will be we can
automatic,
have
yes,
automatic.
correct. Because the
How
DB
is
is
the
too big.
performance?
The performance is all depends on the network connectivity between two servers and whether your replica is being used by users as a read-only replica. If they are using as a read-only replica, then they need to make sure their query is tuned. Otherwise, it can cause blocking to the AG, and the AG will cause blocking to the application.
Let's say replica, maybe we are not using read only. This is only for high availability. We are syncing this data.
Mhm. So if not read-only, then it's actually sync. It's all, then the bottleneck might be the network.
Networking. Okay.
Yeah.
You say right initially manual sync that on flat. What the flat we need to do, right?
Yep, correct.
Can you brief me like what about this flag? How it works?
So what you do, first you back up the DB, you bring it the other side, restore in the replica. Then you need to make sure the log backups also moved. Once they are in the
Okay.
same level of LSN is the log sequence number, then you enable the always on for both servers. It's just by enabling and joining the both servers to both the DBs to the always on. Then after
Okay.
that, always on will continue try to sync it.
Okay.
Yeah,
This is a real-time sync, right?
real-time sync.
Okay. That is okay. Flattening, what is that about? Like just
No, I said that the flagging like always on is enabled. So
oh, okay,
that's
okay.
what I
I
meant.
understand.
Yes,
Oh, okay, okay. Yeah, thanks very much.
welcome.
Hello, Mr. Hamid.
Yeah,
Okay, one question. Actually,
sure.
I'm interested regarding this high availability for the clustering lah. So, for example, right now they have two type of cluster. One is passive active, and another one is all active.
Okay.
So, let's say lah, if I selected active, let's say they have two cluster server. So, I need to use that active. How about the license configuration?
It's
Let's say
all active.
uh,
Any server that is active,
uh-huh.
it needs to be fully licensed. So when we talk about active passive,
Mm-hmm.
means the SQL Server instance doesn't run at all. It's actually in the stop. You are not
Okay.
able to connect. So that is considered passive. If the
Okay.
SQL is running and the databases are also in the let's say standby mode or in recovery,
Mm-hmm.
it's considered passive too. But if let's say any database that is already online and you are able to access is considered active, even though read-only replica is considered active.
Okay, for the recommendation, better we proceed for the active lah, in order we can get the high availability.
Yep.
Okay, good. So I want to know about let's say for current situation. Okay. Let's say I have server and enterprise using enterprise server.
Mm-hmm.
So the license based on core license. Let's say I have a enterprise license with the add core license. Add core lah.
Mm-hmm.
So based on the add core license. So let's say
Yes.
if I want to create the cluster server. So let's say I
Yep.
want to configure as an active. Can I divide that for each lah, for each server? So that means
Yes.
the license question should be same as a current inside that single server. It's like that.
Okay, if you have two servers, like each server 8 core, and you want to make active,
Yeah.
then it needs to be both servers needs to be licensed, means 8 plus 8.
Mm-hmm.
But if you want to set that 4 core for SQL and 4 core for SQL,
Yeah.
then you need to limit your SQL instance to use 4 core.
Mm-hmm. Okay.
Okay, how to limit it is actually here in the configuration. Here, then
Okay.
you need to limit it. But the problem here
Mm-hmm.
is if you limit it here, let's say I say that 2 core for compute, 2 more core, sorry, and 2 more core for IO. Then in this case, the SQL doesn't work as usual. So if
Mm-hmm.
these 2 cores are idle, they don't do anything, SQL will never use them for compute. This is the problem here.
Mm-hmm. So let's say auto track lah.
Yep.
Okay. Okay. For example, let's say lah. Okay. Sorry. Actually, what is the recommendation when we to create the clustering with the active server for
Mhm.
the 4 terabyte data? Actually, what the basic one for the CPU should be 8 core or 4 core?
CPU is actually depends on the workload you have.
Mhm. Okay.
Um, if you have high workload, then it needs to be more.
Okay.
Yeah. Like for
Okay. Let's see.
example, Like for example, if let's say you have a DR site and you put it inside the AG as a DR, the DR, it can be 50% of your production environment, for example. Then you can set 4-core DR, 8-core production, and it still works. It's not an issue.
Okay, maybe after that, maybe have some example how to calculate the CPU versus that transition or versus the storage.
Yep, I will send you guys a document that in the
Mhm.
document actually is the event material. It
Okay.
already explained, I already explained there how to calculate it.
Okay, thank you, Mr. Ahmed.
Okay,
Okay,
welcome.
that's all. Okay, bye.
So any other questions before we proceed? Nope. Okay, now next is what to document. What to document is we need to document the hardware spec, operating system information, network configuration, instance configuration, and the performance benchmark. Like for example, disk I/O test, network latency, CPU and the memory benchmark. We need to keep all of this. The reason is after few months and few years when you guys realize the server doesn't perform well, then you try to run a health check and um, do the benchmarking, then you can do the comparison. If previously network latency was low, but right now it's high due to more devices within the network or the more workload inside the server, then you can justify that. If without benchmark, you are not able to justify any changes. And why do you need the system information, operating system, config, hardware spec, and so on? In case anything happen, or you need to migrate or upgrade the system and migrate the DB, at least you have all the configurations in the document. And you can ask your next vendor or yourself to apply the same configuration. This is the thing that you need to have. And we have it for our own client as well. I think this is the last Q&A. If you have any questions from the beginning of event until now, or anything that is in your mind about your environment or anything you want to ask, please unmute the mic and ask.
Hi, Hamid.
Hi.
I'm Irfan from PTP. Probably just touching a little bit on the topic of performance tuning just now. So, my question will be, how uh, do do we need to do the indexing for every tables and that is available inside the database, or is just the heavy load table only?
Basically the heavy load, and you need to check also what is the load. Is it more on insert, more on update, more on select? If it's select, then yes, you need to create. If it's more on the insertion, then it's better to not create a lot of indexes. Same goes to update. And some tables, even though they are not really a huge table, but they are involved in every workload, they can be problematic as well. So you need to review and create index as well.
All right, got it.
Yep,
All right, thank you.
most welcome.
Hamid,
Yep.
I'm Chong Li. I have
Okay.
a question regarding the DB memory.
Mm-hmm.
Normally when we check the server,
Yep.
um, in order for us to identify whether we have the bottleneck of the DB memory or not, we always look at some performance counter like the page read per second, write per second, buffered heap ratio, cache ratio.
Correct.
Any other easier way for us to something like generate a report, and then the something like the tuning pad will advise us we are hitting the bottleneck on the memory, and what kind of value should we set to the memory?
Okay, basically the memory bottleneck, it varies, honestly.
Yes.
It can be the query that is retrieving a lot of data. It can cause the bottleneck. Memory bottleneck, it can caused by outdated cache plans, means the previously the query executed, it requests for, let's say, 1 GB of memory, but right now it doesn't use 1 GB anymore, but still requesting and approving and SQL allocating 1 GB of memory. The third reason it can cause the memory bottleneck is memory fragmentation, which means that the data pages living inside the memory, already loaded in the memory, is fragmented. It has a lot of empty spaces, which we need to rebuild the index to make sure that we don't have those fragmentation. The fourth one for the memory related bottleneck is the memory capacity itself. Let's say you have 1 TB of database, you have heavy workload, and you allocate 256 GB of memory. In that case, even though your queries are tuned, you don't have outdated plan caches and so on, you need to check the page in and out, the system page swap in out. In that case, you will realize that you will see that OS is actually reading and writing the memory data into the disk, and that's the bottleneck. And if you see that, then you need to increase the memory capacity. Like for example, how to see that when you come to the memory, we have it. We have free, standby, modified, in use, and hardware reserved. So in use is by the apps, modified is the app that modifying, standby is allocated, but it can be removed. They are not active, and we have free. If we have all in use, 100%, and you are seeing the performance issue here, then you need to look at your page in and out. One identification is here. You come to the detail. You need to add one more column. The column called, the commit size, EF delta, and the page fault. These three. So page fault is the total memory buffers that in moved from the memory to disk. And the page fault delta is the one that currently is running. So this is the current number. This is the accumulative number. So if you see that the accumulative for the SQL is very high, then most probably the what I call the total memory capacity is not enough. So you need to add on the memory modules.
Okay, noted.
Yep.
Another question is actually we have the weekly weekly schedule jobs to those to do those kind of like gather state and also the review index. Or is this recommended practice for us to do it weekly?
Okay, rebuilding indexes for certain table and indexes maybe is beneficial, but for certain table and indexes, no. And again, it depends to the workload. For some of my client rebuilding indexes, we don't really do that because they have a lot of transactions, insert, delete, and update. Even though we rebuild index, it doesn't work. After maybe a day, it becomes fragmented. So what we do, we try to tune it by updating the statistics, configuring the SQL instance, trying to release the plan caches, trying to remove the what I call it, the clean but old data pages manually. So that's how we try to, keep up the performance. Because rebuilding index, it will expand the database file, expand the log file, then we need to shrink back. Then once we shrink back, it will cause another fragmentation. And after a day of workload, again, the index become fragmented.
Understand. Thank you.
Most welcome.
Yeah, Hamid, can you go back this task manager just now?
Yep.
Yeah, here you mean to say like phase fault, right?
Yep. Page faults.
This is accumulated.
Correct. This is accumulated.
Will it be like released or it will be how?
No, page fault is basically is for the system data file, which means when we look at here, C drive, let's say by default is C drive. Page options, sorry, file. Hide protected, we don't want, okay. So basically all of them is, where is it? Might be in the D drive. Yep. So in this case, we have this page file sys is here. So all the page fault, it actually goes to here, this file. And it only releases after you restart the server. That's why sometimes you will see that after you restart the SQL, the server, the SQL, the performance boosts up. After 1 day, 2 days, in the third day, you realize the performance drop again. So
Yes.
one of it can be this guy. This guy is full. And also when you look at the task manager performance memory section, you will see the committed. If the committed is almost same as, let's say 37 GB, right now committed is 4.9. If let's say committed become 36, then done. It's actually going to die. So you need to restart the server. So this committed basically is the page size. So how are we going to increase it? If you increase this one, the server will be very slow. I can say that it will be very slow.
This will go up to 32 GB, 37 GB.
37 GB, you see like our server memory is 32, available 27, committed is 5 out of 37. So this 37, this guy is actually this one. So this one can go up to 37 GB.
Okay.
How are we able to change that? Sometimes you need to change it, but I don't recommend that. Once you change it, if you increase it and it grow bigger, then the server performance drops. So when we look at the here, advanced, change here, here. So it says that system manage, you can go for custom size. If you go for no paging file, you are putting yourself in a risk because if there's no paging file, if the memory is full, then the Windows Server will crash.
Okay.
Okay.
Yeah, got it.
So any other questions?
Hi, Hamid.
Hi.
Hi, I'm Vasan here from Skynet. Okay, I
Yep.
wanted to ask regarding with rebuilding index. Just now you mentioned that if a table involved with a crude process
Yep.
and by rebuilding the indexes is not going to work.
Yep.
So are you encouraged to clear the cache on a SQL level or in a table and store procedure level?
I usually clean the cache at the SQL level.
So
So,
entirely.
yep.
Oh, okay, got it. So, I mean, the reason why we are clearing cache instead of we rebuilding, is there any particular reason apart from
Yeah,
not working?
basically rebuilding index for those heavy workload tables, actually improving the performance based on the side effect. Because once we rebuild the index, the planned cache for those tables, it will be clear and it's no longer in use. And when we run the query, SQL will recompile and cache the new plan. So why not we just clean up the plan, outdated plan, instead of rebuilding the index? Then we do that, then we will get the same benefit.
Oh, okay. And how often do we do clearing?
Oh, it really depends. It really depends. Some of my clients once a day I do it for certain environment. Some of them every 1 minute.
Okay,
So
got it.
it really depends how heavy is the workload and how the plan caches get old, how fast.
Okay, got it. All right. Thank you so much, Hamid.
Most welcome. So if no further questions, then again, if you are not our client, you can ask for complimentary service, which is the health check, and we can have a one-to-one discussion. If you are our client, don't worry, you already have that health check. Um, yep. So, yeah.
With this Subramaniam again. Uh, Complementary service in the sense health check, right?
Correct.
What
Health
you do
check.
exactly?
We will run our tool to do the health check. Then we will generate the document for you, and we will
Mhm.
have a meeting. We will explain to
Okay.
you what's the problems, the challenges,
Okay.
and then you guys will take it from there. Yep.
Okay. Got it. Yeah.
Okay.
Maybe. Yeah. I can scan in and I send the details, right? If required. In
Yep.
same. Okay. Thanks, Anish.
Most welcome. So wrap up what we learned is the SQL overview, history, components, features, hardware resource planning, how we do it, and what's the formula and what we need to measure, setup configuration, what we need to do as a best practice, security hardening, what we need to harden, proactive administration, um, what we need to do. And in this case, we introduce the AI DBA, continuous performance tuning, the query to identify the problematic queries and how you are able to do some sort of basic tuning for OLTP environment through the creating index or altering the index. We discuss about the high availability and disaster recovery designs, best practices based on RTO and RPO, and what to document, what is the main items or the topics that you need to document for your SQL Server environment. Thank you for joining the event. I will share with you the recording by tomorrow. I believe that the link will be ready by tomorrow, and I'm gonna upload uh, the slide decks in an PNG format um, into the Meetup group, and also um, I'm gonna email you individually the the material, which is another textbook material for this event, and you can find all the explanation and the formula and the samples there.
Yeah. The recordings, you will share in this group only, right?
Yes, only this group, the Meetup group.
Okay. Okay.
Okay, perfect. let me thank you again for your time, and I wish you all the best. Thanks.
Thank you very much for sharing information. Bye
Most
bye.
welcome, guys. Bye.
Thank you.
All right, thank you.
Thank you.
Bye.
Bye. You're most welcome. Bye.
Thank you, sir.
Most welcome. Bye.
Thank you, Ms. Ahmed, today.
Most welcome. Thank you.
Okay, see you again. Okay, take care.
Yeah, sure.
Bye.
Bye.
Okay.